We're going to now do the last section of this, and this is quite an important section because we're looking at the industrial applications, and this is really a learn work, and we've really summarized this for you. First of all, there's the Haber process, which we're going to deal with again when we get to chemical industries. And the Haber process, you've seen this reaction lots, is ammonia going with hydrogen becoming NH3. The thing is that it is an exothermic forward reaction. When we do it in industry, we have to come to a compromise between a fast rate at a quick price, but a safe price as well, okay, which gives us a high yield. The forward reaction is exothermic, so by rights, the best way to get a great yield is to decrease the temperature, because that'll favor the forward reaction. The problem is if we decrease the temperature, it decreases the rate, so it goes too slowly. So then they make a compromise, okay, because time is an important financial factor. So we can't have the temperature too low because it's going to happen too slowly, and that costs money. So there's a compromise, and that's between 450 and 500 degrees Celsius. So it's going fast enough with an acceptable yield of NH3. We can also change the pressure. There are 4 molecules on the right, 2 on the left. So on the right, whichever way around it is. So we need to increase the pressure. The problem is that it's expensive and can be dangerous. Therefore, we do it under 200 atmosphere. So it's done actually under a very high pressure, okay, because it gives us a very high yield of NH3, and it's one that they can control. And of course, remember, if I increase the pressure, it still goes quite fast. Also with the Haber process, and we haven't talked about this very often with this particular reaction, is we use a catalyst. Please, you need to know this catalyst. Why do we use a catalyst? Because it increases the rate, and we either use iron or iron oxide, Fe2O3. Okay? The next one we're going to look at is the contact process. And this is only the second step. Also exothermic forward reaction. So it has a lot of the same considerations as the Haber process. All right? The forward reaction is exothermic, which means a decrease in temperature will favor the forward exothermic reaction. However, if I decrease the temperature too much, it decreases the rate. Time is an important factor, financial factor. Time is money. So there's a compromise, which is around 450 degrees. So it happens fast enough to get us an acceptable yield at a specific rate. Now, pressure, we would usually increase the pressure, okay? But with this particular reaction, in practice, we get a very high yield. In other words, we get lots of reactant at 1 atmosphere. So we can reduce costs by not making the pressure too high, okay? Makes it easier and cheaper. We can add a catalyst. This one you definitely need to know, which is vanadium pentoxide. You need to know the name and the formula, V2O5. Okay, it's a good catalyst for us in South Africa because we mine vanadium. And we're done.